All right, so um, we so just want to give an example. Suppose we had d to y by d squared plus 4 dy by dt plus 8y is equal to 5. So that the three methods by which we would solve it. The first one we talked about would be the direct method of auxiliary equation. So the auxiliary equation would be k squared plus 4k plus 8 equals 0, and then would want to find k. So so we use a quadratic formula. So what I want to do is go and deal with the things in MATLAB. It might be a bit ad hoc, but so I have online link to MATLAB that I have brought up. And suppose, so the thing was k squared plus 4k plus 8. So if I want to write that down as a quadratic equation to be solved in MATLAB, then I'd write, first of all, I'd write the coefficient as a vector. So x is equal to square bracket, what is it? 1, 4, 8, close bracket. Anybody know the command that you need to find? So this would be my quadratic equation, x squared plus 4x plus 8. Anybody know the command that you would use to solve that? Never hear you. All right, we'll say y, for example. I would do have to write y, we just have to write, we want the roots. So roots s of x. And it will give you minus 2 plus 2y minus 2 minus 2y. So if we have any polynomial at all, let's say that we had x squared, sorry, x to the fourth. So x to the fourth, so that would be 1x to the fourth minus 3x cubed. So that would be, I'll put minus 3x cubed plus 4x squared plus 2x plus 1. And I want to find the roots of that. All right, so I'll just put in roots of x. And so we get the roots of the equation. So if I want to find the roots in MATLAB, I'll just type in roots. All right, so back where we were. So we write down that k is and what would that give us as y being equal? Anybody remember?
Sir, is it the MCAS? Why be minus 2t?
Why? When you're lucky. So you want to catch me in my old age now, you know. We reach the point of life where we start to fellow. Okay. It's the other day. I was booking up some new student. I said, we have a lecture, you know. You remind me of you, you know. As a matter of fact, see him coming down the corridor there, and I see this man coming down the corridor with a green pants and a floral green shirt. I was saying, seriously? And him look vexed with the whole world. So I say, why this man remind you of me? Him say, him teach you the thing yesterday. That was about 4 of them. And him come and ask about it today. And then him start for cuss. Good thing somebody don't stay like that anymore. Never just tell him, say, this is when you have this, the real part, but when you have A plus or minus BJ, solution is E to the A T M plus BT plus N sine BT. Please do not hesitate again next time. Never start cuss.
Yes, sir.
Okay. All right. So we would have that. I know we would have the part with the 5. So the part with the 5 is where to go. We're going to particular solution we're going to try is one with a linear solution. Although we know every time I do this thing is 5 I put on here. So when you differentiate this, it's going to be A and then the second derivative. It's going to be 0. So therefore it's going to be 0 plus 4A. When I put in for dy by dt, dy by dt squared, plus 8at plus b is equal to 5. So that is going to be 8at plus 4a plus 8b equal 5. Now there's no t over there, so 8a must be equal to 0, the coefficient of t. There's no t over the side of the equation. So a must be equal to 0. So 8b, since a is 0, there's only 8b is left, must be equal to 5. So b would be equal to 5 over 8. So therefore the general solution is going to be y is equal to e to the minus t, 2t, m plus 2t plus n sine 2t plus 5 over 8. All right, so this would be my solution. I'll take it from that. From that end. All right, so what would happen now? If I take it from the end of d2y by dt squared plus 4 dy by dt plus 8y is equal to 5. And I take the Laplace transform. So if I take the Laplace transform, This is going to be the second derivative is s squared plus 4. The first derivative is s is equal to 5. The constant is going to be 5 over s. So therefore, this is going to be ys s squared plus 4s plus 8 is equal to 5 over s. So if I make y s the subject of the formula, that's going to be 5 over s to s squared plus 4s plus 8. Let me just segue a little bit. I'm not going to be dealing with everything, but just wanted to starting point. If I wanted, so my denominator, x, I wanted to put it in MATLAB. The denominator was 148. I wanted to put the transfer function that I have in MATLAB 1, 4, 8. The numerator, I'm going to call it y. Is so now it has to be the same order as the denominator, which is 148. It's only 5 that is on top, so I'm going to put 0, 0, 5. And then, so I'm going to call it G. For example, I can call any letter or anything that I want to call. Is going to be the transfer function of y. Y is the numerator, yeah. For x, which is the denominator. And it will give you the transfer function. All right. Whatever you want to do with the transfer function after that is up to you. So now, so we said that's the transfer function. No, it wasn't that. Anyhow, leaving that alone. I just using MATLAB to show you. That it was s into s squared plus 4s plus 8. All right, so to sort out this now, this can factorize. So we're going to have to sort it out in partial fractions. So this is ys is going to be equal to a over s plus bs plus c over s squared plus 4s plus 8. So we're going to have a into s squared plus 4s plus 8. I don't know our circumstances, we just put them back together across the cross multiply. Plus b s plus c times s is equal to 5. The numerator is 5. So s equals 0. This part, this wire goes, and this is 0, and this is 0. So you get 8a is equal to 5. So a is equal to 5 over 8. If I multiply it out, I'm going to get a s squared plus b s squared. So I'm going to compare s squared So the A S squared plus B times SBS times S squared. There's no S squared over here, so therefore A plus B, the coefficient of S squared over here must be equal to 0. So therefore B must be equal to the opposite of A. A is 5 over 8, so B must be minus 5 over 8. And then now if we compare, we have A times compare, multiply out this now. This is S4AS plus CS. When we compare S. Yes, Mr. Stewart?
Yes, sir. Good afternoon. Just letting you know that someone said that their laptop crashed. I believe he was the one who was supposed to be doing the recording, but because his laptop crashed, someone else would have to take over in terms of continuing the recording.
All right. So you're volunteering?
I do not have my, hold on, give me a sec.
Or you can ask somebody else to
I'm
volunteer.
already recording.
Okay, no problem then.
Okay. I was wondering when you say he, because I know that. Okay, so 4A plus C there's no S over this side, over on the right hand side. So again, that must be equal to 0. So C must be equal to minus 4A. And that is going to be equal to minus 4 times 5 over 8, which is cancelled. That is 1, that is 2, minus 5 over 2. So therefore, YS is going to be equal to A, which is 5 over 8 times 1 over S. Plus BS. B is minus 5 over 8. And this is going to be 1 over S squared plus 4S plus 8. BS, so this is S. I was trying to make it whole, but all right, over on the next page. So we have YS is equal to 5 over 8 times 1 over S minus B is 5 over 8 S over S squared plus 4S plus 8 plus C minus 5 over 2 to 1 over S squared plus 4S plus 8. So, forgot to bring up Laplace transform. One second while I bring up Laplace transform.
Everything all right, sir?
No, wait, I'm just trying to bring up the Laplace transform, but I have a slow computer. Okay, where were we? All right, so to use, we know the inverse Laplace transform of this 1 over s is just 1. So now this part here, what we are going to do is complete the square. Now, rough work, s squared plus 4s plus 8. My must teacher table to take half of that squared. I will plus 8 minus the same thing outside, so the same thing out here. So that is s plus 2, 8 minus 4, so that is s plus 2 squared minus 8, 4. Plus 4, sorry. All right, so now what is yt going to be equal to? All right, so this is 5 over 8. Let me put out way out here, t is greater than or equal to 0. So I don't have to put the ut beside it. So that's 5 over 8. So now, let me go to the transform table. All right, so we went to we have our thing is s over s plus 2 squared plus 4. And so and then we have 1 over s plus 2 squared plus 4. So let's deal with the easier one first, this one here. So we have to put a 2 up here, the b squared is 4, and b has to be at the top. So we have to put a 2 up here. But if we put a 2 up here to get back to 1, we have to put a half outside. So therefore, that is going to be e to the minus 2t, so the minus a, and the sign change. So this is plus a, so the sign up here must be minus. Sine b, which is 2, sine 2t. So that part there is e to the minus 2t. Oh, and we put the half back. Sorry, the half is here, so I put back the half. Now the more distressing part now is this part here, s plus 2 r squared. So we'll start with this. So we're going to put s over s plus 2 squared plus 4. So we're going to go s plus 2, s plus 2 squared plus 4. But we put a plus 2 there, so we have a minus of it. Very well. So we're going to have a minus 2 to s plus 2 squared plus 4. So this part corresponds to, if we are following this down here, is going to be e to the minus 2t cos 2t. And this part here, we already is going to be equal to e to the minus 2t sine 2t. So if we put the two of them together, let me go back. age of failing memory, so I'm going to use the latest device and take a picture so I can write it back over here so I remember it. So this is 5/8 minus 5/8. No, this part here is what we just wrote down. Take the picture for me. Try to remember what it is. That it's e to the minus 2t cos 2t minus
Minus, yes, sir.
e to the minus 2t
Sine.
sine 2t minus 5/2. And this one here,
Of
e to the minus 2t sine or cos?
sine, sir.
Sine 2t, and t is greater than or equal to 0. If we didn't put the t greater than or equal to 0, we would have to put a ut beside each of these, which we can't bother with. That's why we just put t greater than or equal to 0. And then now we simplify that. 5/8 minus 5/8 e to the minus 2t cos 2t, and this is 5/8 minus 5/4. So let me use my calculator. 5/8 minus 5/4 equal. So this is minus 5/8 e to the minus 2t sine 2t, t greater than or equal to 0. So if you notice something here now, this solution is specific, whereas the original one gives us 5/8 and it gives us m and n. Now, the reason why this Laplace one gives us such a specific answer is assume that the initial condition all right, if I don't put in any initial conditions when I'm using Laplace transform, the solution is going to assume that the initial conditions are 0. The other method that I was using did not assume any initial conditions. So therefore, that's why I'm ending up with m as one coefficient and n as the other coefficient. This one is giving me 5/8 because the solution from the get-go, I assume that the initial conditions were 0. All right, so that's 2. So now I want to use MATLAB now to solve the same differential equation. So we want to use MATLAB and solve the same differential equation. Now, I am going to sit here and pretend that I know the code, but all you do is type in that you want to know the code, and then the code will be given. So I'm not working from memory. I have a sheet of paper in front of me. All right, so let's go and see what we will do if we ask MATLAB to solve the same equation. So let me clear the screen. So the first thing that I want to do is use the symbolic function of MATLAB. So I'm going to type in SYM, why this thing here freeze. S, what happened here? Let me go again. SYMS. Oh, shoot. Sure. And the function that we have is y of t. So I'm going to put y of t. So what we're working with is a function that we're going to call y of t. We're going to take dy dt and so forth. So we declare it as y of t. So MATLAB can solve all different types of equations in symbolic form. So we have to declare what the symbol is that we are using, and is y, and it's respect to t. We're going to be differentiated with respect to t. So that's the first thing that we have to say. The second thing now is that we're going to differentiate. So our ordinary differential equation, that's the equation that we have, is equal to. The first part is d2y by dt squared. Can I write it down? Can I write on the screen? So it's d2y by dt squared plus 4dy dt plus 8y equals 5. So first thing that we're going to write is that is a differential equation. So we're going to write diff y. We differentiate in respect to y and t, and we're taking the second derivative, so put in 2. And then it is plus 4 times the derivative. So we put diff y comma t plus 8 times y is equal to. So equal to is 2 equal sign. 5. So that is our differential equation. That's the differential equation that we want to solve. So solve that differential equation. So we have to tell it to solve it. So we're going to say y solve. And with respect to t, it's going to equal to the solution. We're expecting to solve the differential equation. So we say d solve. If we had a regular equation, we would put in solve. We want to solve the ordinary differential equation above. And here we have our solution. Once again, it gives us if we didn't put in the we didn't put in the initial conditions, so therefore it's going to give us a general solution. So as engineering students, I'm just putting these out there. So there you have all different type of methods to solve a differential equation. So it doesn't really, the approach at this point, we don't care about the approach. We just care that you know the method of getting your result. So so any questions up to there?
So if we use MATLAB, right, sir, we will have to still find C1 and C2.
No, if you want to solve a differential equation with putting in the initial conditions, you can put in the initial conditions and it will find C1 and C2 for you. I didn't put in the initial conditions in this particular MATLAB, but you can put in the different, you'd have to put in the initial conditions. COND, and then you'd have to put in what are they, but I didn't put any in the equation. What I need to do is put the MATLAB link and it will tell you how to solve different differential equation. But if you have the differential equation, you just put in condition one, initial condition one, initial condition two, and it will give you the let me go back and show you what I talked about. So where are we? Give me a sec. Oh, okay. That I'm trying to find back with the MATLAB screen. All right, so suppose we have that. So let's go back and start over. So in it, we said starting back over the differential equation. So this is the differential equation, and then the next thing is that we have the ordinary differential equation. So now I'm going to put in condition one. So that's y of 0 is equal to 1. Condition 2 equal d, the derivative with respect to y of 0. I'm just putting in some arbitrary conditions, is equal to 1. Did not recognize d by 20. Give me a second there and find out. Find out y not recognize b, y equals 0. Condition 2. Sorry, give me a second. I'm not seeing why it's not recognizing. Oh, I had to declare it as well. Sorry. Sorry, I had to declare it. I didn't. Where am I? Right. So, oh, you're not seeing the screen, right?
No, sir.
Oh, sir.
All right. Oh, okay. So I have to say, oh, you know, D, I have to tell the, where is it? I have to tell MATLAB said D, oops, D, Y equal to D, I, F, F, the derivative of Y, T. And then now I can put the second condition in. All right. And then now it is going to be D solve, D solve. Okay. Oh, first of all, I have to put the differential equations in a vector. So leave that out. Oops. Chop. Sorry about that. It's mixing up the things. I didn't want to put in this. I didn't want to put in this command. That's it. I have to put in the conditions, you know. So I'm going to put CON dt, put the conditions as a vector equal to condition 1 if you see me at the screen right here now, I have to be looking over my glasses, and so that is why we're not seeing so well. So I'm apologizing for that. If I turn on the camera, you look at me, you'd be laughing. All right, so condition 1, condition 2, CON, what did I call it? COND. Yes. Okay. So I put the condition, the two conditions, and then now I'm going to solve. I'm putting in the condition. CONDT. And then it will give you the specific solution, as you see there. All right, so if you put in the conditions, then it will solve it specific to the conditions. Okay. Get everybody gone?
Yes, sir.
No, sir, we're here.
Okay. So, we just wanted to point out that you have the various methods that you can use to solve a differential equation. And you are free to use whatever methods you want. When you model a system, then you are going to use the differential equations to find out things about the system. Then you can, once you model it and you have to solve, you have various methods open to you. Okay. So we're stopping. Like I said, today's class would be short. So we just wanted to do those three things and show you.
Well, believe it or not, it wasn't really short, sir, because you actually ended on time.
Okay. Well, all right. So good. So what I would like to do is next week give you a self quiz. I'd ask you to do a little model and find some solutions for it using the various methods. It's a self quiz because it's not us, we're not taking collecting the marks. We're just going to try it and then see at the end to mark yourself and see how well we are doing. We did that. So the MATLAB that I have here is trial. And I'm just using it from the browser. So you can do the same thing too. All right, I just put in, I didn't put in a school email, I put in personal email and click on trial and from browser, or you can download it. But that trial is for a month. Okay, so all right, so we stop in here. And next week we're going to be talking about matrices and state space. Okay.
All right, sir.